So now in this video we'll discuss about some basic things or basic features about the C++ programming language. And initially we need to discuss about what are the different characteristics of the C++ programming language, what are the tokens which are used. But I think if you are coming here to study the C++ programming language, then I believe that you already know some of the basic things about the C programming language, because most of the things which are valid for the C programming language, they are also valid for the C++ programming language. Okay, now in case of C++ programming language, we use something called as data types. Okay, there's something called as, let me rub it. Now there's something called as data types. Now there are three types of data types we generally use. First is called as primitive data types. Primitive data types. The second one is called as the user defined data type. The user defined data types. And third one is the derived data types. Derived data types. Okay, so I could have written it like this. This is the first one, this is the second one, and this is the third one. Okay, so for the primitive data types, there are some data types like we have integer, character, float. We have integer, we have character, we have float, we have long. Okay, so long is actually not a primitive data type, so we use double. Okay, so you can say long is also a primitive here. Long, okay, right. So long is also a primitive data types here. Now the size of integer is of 4 byte. The size of float is of 4 byte. The size of double is of 8 byte, as well as the size of long is more than that. Okay, so we'll do one thing. We know what is the size of character. I know what is the size of long. In case of C programming language, the size of character is of 1 byte. The size of long is of 4 byte. And we'll see some of the data types, some of the things which we use before them. For example, we know something called as short int. There's something called as long int, and sometimes instead of writing long int, we only write long. Okay. And then when we discuss about the user-defined data types, now the user-defined data types in case of C language, we studied structures. Now those I'm sorry. Okay. For the user-defined data types, we studied structures. So those structures are also available in C++, as well as there is an extension of structure which is actually called as a classes. So classes, actually they are the user-defined data types. A part of classes we can have unions, and we can have something called as enums. They are also available in as a user-defined data types. Then we have something called as derived data types. Derived data types like arrays, and there is some other new data types which are there like vectors, etc., etc. So we'll take them one by one. So initially we'll start with the primitive data types, and as I told you, you already know what is an integer, what is a character, what is a float, what is a double, and what is a long. I believe you already studied my videos of C programming language. So let us discuss about the integer data type. So here we'll be making programs related to the integer data type. Now you can see I can store some integer variables inside the integer data types. So we'll start with the primitive data types, and then let us do one thing. First of all, let us start with the first data type, that is called as integer as a data type. Now what is the work of the integer data type? It stores integer number. It stores integer numbers. Now only storing integer number is not enough. We have to print, or we have to use those integer numbers. Okay, so what you can do is you can declare a variable like this: integer a is equal to 5. That means there's some memory is allocated which is storing a. Now we can perform various actions on this integer variable a. That is fine. I think this is a very simple thing, you already know this, but for the sake of completion I'm covering it. So we have integer a is equal to 5. That means a is this variable which is storing the value 5. Now I can do cout, and I can print the value of a. Fine, that's okay, that's good, right? Now I can just go to build, and I'm running the program, and now it is printing the value which is 5, which you can see here. Okay, so those who are concerned about what compiler I'm using, this is a code blocks compiler which is using GCC as a background. So in the code blocks compiler I'm executing the C++ programs. Okay, and here you can see in this compiler, this is the header file. We have something called the header file. We have this as using namespace std. So we'll be discussing about this one and why I'm writing the namespace std, because in the initial versions of C++ programming language we used to execute them on Turbo C, etc, etc. You have used those software in your colleges, and most of the colleges are not actually using code blocks, but the latest one, or you can say some colleges, very good colleges, they are using code blocks to teach the C and C++ programming language to the students, and even the data structures. And we know there's a main function here. Okay, that I think that you understood. That is not a problem at all. You have an idea about this one. Okay, now here in this case you can see this integer is a variable of type integer and is storing the value 5. That's fine, and I'm using this cout to print the value cout. Just like in C language, we used something called as printf statement. We used printf to print some values, right? And we used scanf to scan some values or to take input from the user. Okay, so this is used to print something on screen, and this is used to print output. Okay, so this is to take input from the user, Okay, now in case of C++ programming language, we mostly use cout and cin. Cout is used to print something onto the screen, and cin is used to print cin is used to take input from the user, and cout is used to print something on the screen. Okay, now as I told you that C++ is a superset of C language. If this is representing the C++ language, then C++ is actually a superset of C language. That means these functionalities of printf and scanf, they should also be available in C++. And yes, they're available. You can even do printf and scanf in case of C++, right? But there you have to use a different header file. So here I'm using the header file which is #include stdio iostream.h. iostream.h, the full form is input output stream. Input and output stream. This is iostream.h. Okay, and this iostream.h is actually, it is defining the functionalities of cin and cout, that is giving some output to the user and taking some input from the user. Okay, but if you want to use these functionalities of printf and scanf, then I have to include that header file which is stdio.h, which is the standard input output.h. Now let us see, can we do that here in this program? So can we take input from the user with the header file which is stdio.h here? So I'm going to write #include stdio.h as a header file. I'm so sorry. So to change the line, I can write endl. Now I can also do printf %d comma a. That means I'm printing the value of a again. Now if I go to build and I build and run the program, now you can see I'm printing the value 5. There is no errors in the program, right? There is no errors in the program. We are still printing the value 5, right? That means you can even use the functionalities, you can even use the functions which are available in C and C++, which are available in C language, even in the C++ programming language. You can use printf, you can use scanf. That is fine, that's available. I think you already understood this, and I've explained this. Okay, now we were discussing about the data types, which is the integer as a data type. Now I told you in the previous video what is an integer as a data type. For integer as a data type, the size of integer, so we need to understand what is the size of integer, number one. Second, how can you store the integer values? That means I'm telling you it is storing integer values, okay, and you can easily find out what is the maximum value and what is the minimum value. So we'll do one thing. So integer values. Third one is we'll be discussing about the range of integer values which this variable can store, and a part of that we discuss about size. We take integer values, and third one is range, and fourth one is some examples. Okay, some examples. The first one is the size of integer value variable. So as I told you, the size of integer variable is of 4 bytes. But how can you tell? How can you prove that the size of integer variable is 4 bytes? So what we can do is we'll be writing a program for this, which will tell what is the size of an integer variable. Now I'm going to write. There's something called as size of function. So I'm going to write the cout statement, and here I'm going to take the size of function. In the size of function I'm going to write int. Now this size of function is just going to return the size of the integer variable, okay, and here I can even write get char, that means get character, okay. I think you already know this, get ch, this get catch. So let us execute this one. It is saying the size of integer is 4 byte, and because of this get char, it will take one character as input and then it will terminate, okay. So let me do one thing. Let me change the line, that is end L. Okay, now you'll see why I used get char. Okay, so again I'm going to go to build, and I'm going to build and run the program. Now here you can see we printed the value 4, and this 4 is actually because this is the size of the integer variable. The size of function is printing the value 4, and this get char is, that means we are going to take one character from the user, and that character can be anything. For example, we can take a next line character from the user. To take the next line character, I'm just going to press enter or return. So enter, and then it took that value, and then you can see we can easily write. So the program execution finished. So execution time of the program was 24.71 seconds. 717 seconds. So the program was ran for 24 seconds here. Okay. Now that was the first thing. What is the size of integer? Size of integer is of 4 byte. Second thing is what is that it takes integer values. Okay. It takes integer values. How can you say it takes integer values? I can store integer a is equal to 5. That's fine. That's okay. Obviously, right? Now I can print cout the value of a. That's good. And if I'm just going to print the value of a, then I'm doing end L, so it should print this value. I'm going to go to build, and I'm going to run the program now. Okay, so there's a semicolon here. Build and run the program. Now you can see it printed the value, which is 5. That's okay, that's fine, that's very good, I understand that. But what if I try to store 5.3 inside this integer variable a? Now what is this 5.3? First of all, you understand what is this 5.3. What is the type? Can you say it is a float variable value? No, it is not a float value at all, because any point number by default is a double number. But the C and C++ compilers, they are having automatic type conversion, right? So that is automatically they will convert this to integer or float. So we'll be having automatic type conversion. Okay, so now if I try to execute this program, I'll go to build and I'll try to execute this program. Now you can see it is still printing the value 5. It is not round off. Round off means sometimes what people do is, when I'm saying round off, they think that if I'm writing 5.9, then 5.9 should be printed as 6. No, this is called as round off. We are not rounding off the values. Okay, we are printing the exact values. For example, here even if I convert it to 5.99 or just 5.9, now if I go to build and I try to run the program, now you can see it is still printing the value 5. That means from this variable it is only accepting the integer part, it is not accepting the decimal value, that is 0.9 value. Okay, this is the first thing. Second is, can I take a better example for this one? Obviously yes, I can take. Okay, so let me show you a better example to show that it takes integer values. Okay, so what will be that example? Just assume that if I'm going to take integer a is equal to 5 divided by 10. Now this 5 divided by 10 is 0.5. No, it is not 0.5. Already discussed this in the previous videos, that 5 divided by 10 is actually 0. Why it is 0? Because 5 is an integer, 10 is an integer, and when you say integer divided by integer, then it is going to give you only integer. Integer divided by integer is integer. Okay, so that means when I'm saying 5 divided by 10, it should only give an integer value, which is 0. But if I do 5.0 divided by 10, now this is a double number, assuming that saying, for simplicity I'm saying float, because most of you are more comfortable with saying float, but this is actually a double number by default. Unless you store this double number inside a floating point variable, then it will be converted to a float. Okay, see, let me tell you one thing. Let me tell you a very basic difference. If I'm writing 5.0 or 5.1 or any value after point, it can be 5.99. Now any variable, any value, this is a by default a double number. But if I'm writing 5.0f, now because of this f, this particular f, now this variable is of type float. Okay, even if I'm writing 5f means this variable is of type float, or this value is of type float. To give a value as float, you have to implicitly write f. You have to write it f. Okay, without writing f, it will be a double value if it is having some kind of decimal or point after this one. Okay, so we'll discuss that in the later videos. Don't worry, we'll take that example when we'll discuss about the float. Now right now we are discussing about the integer variable. Okay, now you understand that when I'm saying 5 divided by 10, that means it is going to print a value which is integer value, and that integer value is 0. So even if I'm going to execute the program, I'm going to go to build and run. No, again you can see the value which is printed is 0. So it printed a value which is 0. Okay, that's good, that's fine. I understand this. I know you also understand this one. Good. Now what if I'm writing integer a is equal to 5 divided by 10 multiplied by 6, or integer b is equal to 6 multiplied by 5 divided by 10. These are two different values. 5 divided by 10 multiplied by 6, or 6 multiplied by 5 divided by 10. Those of you who are watching my videos for the first time, then you understand, then you will say that definitely these two are exactly the same values, but they are not the same values. I already explained this one. Why? Because we are not studying mathematics at all. In mathematics we follow the rule of BODMAS, right? That is BODMAS rules. First of all, we are going to do brackets, then we'll solve off, then we'll solve division, multiplication, addition and subtraction. That means division is having higher priority as compared to multiplication. But in case of C, C++, .NET or Java, in these programming languages, we do not consider the BODMAS rule. We consider something called as operator precedence and associativity. Now, when I'm saying operator precedence and associativity, operator precedence and associativity. Now this operator precedence of division, multiplication and modulus, it is exactly the same. Precedence of plus and minus, it is exactly the same. But associativity of these operators left to right, left to right, left to right. When I'm saying left to right, it means if I'm having A multiplied by B multiplied by C, if I'm having two multiplications operated together, now because the precedence of both the multiplications are same, so we are going to take the associativity into consideration, and the associativity is left to right. Okay, that means initially we'll evaluate this one first and then we'll evaluate this one. That means in A multiplied by B multiplied by C, initially we'll be evaluating A multiplied by B, then we'll be evaluating the result with multiplication by C. Now in the same way, when we talk about this expression, that means integer A is equal to 5 divided by 10 multiplied by 6. Now in this expression, the precedence of multiplication and division is exactly the same. So if the precedence is same, then we take about the associativity. So in the first expression, we'll be evaluating 5 divided by 10 first, and then we'll be evaluating multiplied by 6. Now in the second expression, first of all we'll be evaluating 6 multiplied by 5, and then we'll be evaluating multiplied by 10, or sorry, divide by 10. So the output of the first expression is 5 divided by 10 is 0, 0 multiplied by 6 is 0. So output of the first expression will be 0. The next expression, 6 multiplied by 5, this 6 multiplied by 5 is 30, and 30 divided by 10 is 3. So output will be 0 and 3. So let me prove it to you. If this is difficult to follow, let me prove it to you. Okay, so I'm going to take two variables here, two integer variables here, that is a and b. So I'm doing integer a is equal to 5 divided by 10 multiplied by 6, and then I'm taking integer b is equal to 6 multiplied by 5 divided by 10. Correct? Now I'm printing the value of a as well as, okay, I'm printing the value of a as well as I'm printing the value of b. So this is the value for b and I'm printing the value of a. Okay, now let us print. So I go to build, I'm going to build and run. So again you can see the values which are printed are 0 and 3. 0 and 3. Make sure don't make this kind of silly mistakes in your future. It is going to print 0 and 3. This is about the integer variables. Okay, correct? I think you understood this one. Now the third point is we want to discuss about the range of these integer variables. Range. So let us discuss about this one first. Let me wrap this extra spaces, extra values here. Okay, let me do one thing, let me delete everything. Fine. So the range of integer variables. Range. And what is this range? Range means what is the maximum value it can take, or what is the minimum value it can take. As I told you, the size of integer variable is of 4 bytes. In case of 4 bytes, how many bits are there? There are 32 bits in 4 byte, and these integer numbers are 2's complement numbers. They are 2's complement numbers. 2's complement means that means if there are n bits to represent, then the minimum value will be minus 2 raised to power n minus 1 to maximum value will be plus 2 raised to power n minus 1 minus 1. This is the benefit of using 2's complement numbers. Okay, now we don't use 1's complement, we don't use 0's sign bit representation in C and C++ language. In some of the books it is given as wrong. Keep it in mind. The minimum value in 2's complement, if there are n bits, then it is minus 2 raised to power n minus 1 to maximum plus 2 raised to power n minus 1 minus 1. That means if the integer is of 4 bytes, that means 32 bits, so the minimum value will be minus 2 raised to power 31 to maximum value will be plus 2 raised to power 31 minus 1. 2 raised to power 31 minus 1. Now what is this minus 2 raised to power 31? Okay, so if I am writing 2 raised to power 31, then this is actually 2 raised to power 10 multiplied by 2 raised to power 10 multiplied by 2 raised to power 10 multiplied by 2, then only 2 raised to power 1, then only it is 2 raised to power 31. We know what is 2 raised to power 10, it is 1024, this is 1024, this is 1024, and this is 2. So we are multiplying these numbers. So let us do one thing, let us open a calculator and find out what is this value. So we'll go to the start menu, and this is calculator. Yeah, so this is calculator. Now let us evaluate this value. So it is 1024, and we'll be having multiplication 1024, again multiplication 1024, again multiplication as 2. So the value is this much. This is a very large number. Let me write it down for you for simplicity. So this value is 2147483 This is the maximum value for this integer value. And what is the minimum value? Minimum value will be 2147,483,647. That means you subtracted 1 from here. So this is the minimum value actually. This is the minimum value and this is the maximum value. So minimum value will be minus this one, maximum value will be plus this one. So let us try it out. Let us try to store these values inside these integer variables. Okay, and let us execute this one. So we'll be having integer a is equal to minus 2147483 and then I'm trying to print the value of a. Okay, so let us execute, build and run. So happily it printed this value and there is no problem whatsoever. Fine, that's good. What if I give a lower value than this, that is 2649? So that means build and run. Now you see this is not printing a value which we wanted to print, right? It is not taking this value as a negative number. So when we took minus this as 48, now it is printing perfectly. It is saying it is a minus 2147483648. That means it is a negative range. But if you take a value greater than this, now it is not taking a value which we wanted to print, and rather than it is giving some random values. Actually this random value is about how this number will be stored inside the memory and then how this number will be represented. Okay, so this is about the negative part. But if we have a positive number, so in case of positive number, the maximum value can be this much as we have written. So if I build and if I run, so the value is 2147483647. That's perfectly fine. It is printing a perfect value. That's correct. What if we try to print 8? Now it should not print the exact value. So you can see it is printing a negative value. How? Why? Because the binary equivalent of this value is actually representing a negative number, because we are using 2's complement numbers here. So for this you can go back and you understand what is the 2's complement representation for this one. Okay, I think this is clear, sound and clear about the integer variables. Now let us discuss about the other variables, that is character, float, and we'll be discussing about the long and all these variables in detail after this. Okay.